Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. If a normal distribution with mean mu and variance sigma squared greater than 0 has 46th percentile equal to 20 sigma, then mu is equal to, and we have 5 answer choices. Please note that the first 4 are all a function of sigma, and the 5th one is that you can't determine that mu in terms of sigma. Here's the solution. So let x be the random variable described in the problem. That x minus mu over sigma has the standard normal distribution. Let us write x 0.46 for the 46th percentile of x. So we have that the 0.46 is the probability that x is less than 0.46, which is the probability that x minus mu over sigma is less than x 0.46 minus mu over sigma. And that would be probability that x minus mu over sigma is less than 20 sigma minus mu over sigma, because we are given that x 0.46 is equal to 20 sigma. And of course that x minus mu over sigma is z, standard normal random variable. And the probability that z is less than that number, 20 sigma minus mu over sigma, is 0.46. So that number, 20 sigma minus mu over sigma, is the 46th percentile of the standard normal distribution. So let's try to figure out what the 46th percentile of the standard normal distribution is. On the table, on the exam P, you are given the table for the standard normal distribution, and in that table you find from the table that phi, the cumulative distribution function of a standard normal distribution, at 0.1 is equal to 0.5398, and at 0.11 it's equal to 0.5438. Then we're not given the values, by the way, for negative numbers in the table. That's why I looked at these, because 1 minus 0.46 is 0.54, and phi of minus z is equal to 1 minus phi of z. So based on the values we looked up, phi of negative 0.1 is 0.4602, and phi of negative 0.11 is 0.4562. And 0.46 is between those two numbers, 0.4602 and 0.4562, and we're going to figure out where roughly that 46th percentile is through linear interpolation. The probability that we want is 0.46, and that is a certain fraction of the distance between 0.4562 and 0.4602, and I calculate the fraction of that distance here. That's 0.4602 minus 0.46 divided by 0.4602 minus 0.4562. That turns out to be 1 over 20. So the distance from 0.46 to 0.4602 is 1/20th of the distance from 0.4562 to 0.4602. And this means that the 46th percentile is approximately 1/20th of the distance between negative 0.1 and negative 0.11, down from negative 0.1, because 0.4602 corresponds to negative 0.1. And we can get the desired percentile of the standard normal distribution using linear interpolation by taking it to be approximately negative 0.1 minus 1/20th times the distance from negative 0.1 and negative 0.11, which is negative 0.1 minus negative 0.11, and that's of course 0.01. So what we have is negative 0.1 minus 0.01 over 20, and that's approximately negative 0.1005. Therefore, what we get is that the percentile we just figured out, negative 0.1005, is equal to 20 sigma minus mu over sigma. And we solve this as an equation in which mu is the unknown, and we get mu to be approximately 20.1005 sigma, and that's answer choice C. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.